In this video, I'm going to do some MCQ questions based on polynomials from the chapter from the book NCERT Exemplar. Now, the first question is that this is under root 2 and we have to find this is a polynomial of degree. As you can see, this is under root 2, whether it's a irrational or rational, right? Although it's an irrational over here, is a constant polynomial. And the constant polynomial has a degree 0. This is what you have to keep in mind, that a constant polynomial has degree as 0. Now, many of you write this 2 under root 2 and you write this as 2 raised to the power half, and you consider half to be the sometime as the degree. You should know that the degree of a polynomial is the highest power of the variable and not that of the constant. In the next question, we again have to find the degree of this polynomial. Now look into this. Here you can see that although in the beginning the highest power appears to be 5, but this is actually 0. 0 multiplied by any number is 0. So we need to eliminate this portion, like considering it is not there, because 0 multiplied by any number is 0. Now let's say this is also 0, so this also gets eliminated. What we finally left with, these leftover polynomials are these, and you can see that this has a power of 4, 1 and 0, right? So therefore the highest power has to be 4 here. That's the degree, and the degree is 4 in this case. Next we have to find the degree of 0 polynomial. 0 polynomial is what? I mean 0 is called a 0 polynomial. 0 is called a 0 polynomial. Now let's first understand, when I write 2, which is a constant polynomial, say minus 3 is a constant polynomial and 0 is a 0 polynomial. Now for a constant polynomial, say this, or maybe minus half, these are constant polynomial. The degree of a constant polynomial is 0. The degree of a constant polynomial is 0, but the degree of a 0 polynomial is not defined, right? This is degree of a 0 polynomial. So let's figure out, many of you take 0 as a constant. 0 is not a constant in terms of polynomial. It is a 0 polynomial, and 0 polynomial has the degree as not defined. We say that degree of a 0 polynomial is not defined. In the next part, you can see that we are given a polynomial, this, and we have to find p root 2, p2 root 2. So let's see how can we do this. So what we have to do is just plug in the value of x as 2 root 2. So it is p 2 root 2, replacing x with 2 root 2. What we'll get this as 2 root 2 square minus 2 root 2 times, again an x over here, so we'll replace this with 2 root 2 and then plus 1. Now the square of 2 is 4 and the square of root 2. What I mean to say here, that we have to find the square of this. 2 square is 4 and root 2 square is 2. So 4 into 2 is 8. So this is 8 here, minus again 2 root 2 into 2 root 2 is again 8, because 2 into 2 is 4 and root 2 into root 2 is 2. 4 into 2 is 8 and plus 1. Plus 8 minus 8 get cancelled, so we get positive 1, or say 1 is the value of this 2 root 2. Question number 6, we have to find the value of this polynomial at x is equal to minus 1, or say when x is equal to minus 1. Same way, we are going to just replace this x with minus 1. So it is 5 into minus 1 minus 4 times minus 1 square plus 3. So 5 into minus 1 is minus 5. And you know the square of a negative number is positive. So minus 1 square should be positive 1. Let me clarify this again. This is when this is minus 1 raised to the power 2. Minus 1 raised to power an even power is always 1. So we get this as 1. Now further, this is minus 5 minus 4 plus 3. This is minus 9 plus 3, and that comes out to be minus 6. So minus 6 is the correct answer for this. We are given in the seventh question, we are given px is equal to x plus 3. Then we have to find px plus p minus x. Now, let me do the one way which you actually do in the exam and you do it correct. What you write px as x plus 3 and you write p minus x as, say, some of you write minus x minus 3, other of you write, say, x minus 3. This is wrong. So what you have to keep in mind, let's do it in the correct way. We have px is equal to x plus 3. So if I say that p minus 5, so what do you do actually? You replace x with minus 5, right? You don't change the sign of a constant. So here we are also going to do the same way. We have to get p minus x. So I'll be writing p minus x and we'll just change the variable x as minus x. The constant and along with its sign should remain same. Now we need to add these two. As you can see, we need to add these two. So I'm adding these two. So the left hand side will remain as px and p minus x. And the right hand side, when added, I'm showing you the working. This would be, first is x plus 3, another is minus x plus 3. When added, as you can see that x and minus x get cancelled. So we get this as 6, 3 plus 3, that is 6. So this is the correct answer for this question number 7. Now we had one question where we are finding the degree of a zero polynomial. I told you the degree of a zero polynomial is not defined, right? But this is not the degree. They're asking for the zero of a zero polynomial. So it should remember the zero of zero polynomial is any number. Let's do once again. If it is a degree, right, instead of a zero, if it's a degree of a zero polynomial, then we say that it can be, it is not defined, right? I should repeat. Here we have a question where we have to find the zero of a zero polynomial, but in case if they ask you the degree of a zero polynomial, then it is not defined. But over here we have to find the zero of a zero polynomial, which is any real number. In the next part, we have to find the zero of this polynomial. So to obtain the zero of a polynomial, we actually equate it with 0 and solve it. Finding the zero is same as finding the solution of a equation, right? So first we equate this with 0 and then we will find the solution of this, which is the value of x. So on transposing 5 on the other side, it's 0 minus 5, which is minus 5, and then transposing 2 on the other side, minus 5 by 2. So minus 5 by 2 is the correct answer. In this question, we have we have to find one of the zeros, right? We don't have to find all the zeros. So one way is to plug in each of them one by one to check which of them is the zero of the polynomial. The easier way is to factorize and find all the zeros that we have. That will be the shorter way. Now, as you can see that this is a polynomial where there is no perfect square. No, this is one is only perfect square. There is a perfect square, that is 4. So there are 3 terms in which there is only one perfect square. So we factorize by the method of splitting middle term. So what we are going to do, we are going to multiply 2 with 4. That will give you 8 and split 8 into 2 factors so as to get 7. Now, needless to say, we can write 8 as 8 into 1 and their difference will give you 7. So I'll do it. This is 2x squared plus, I'm splitting this 7x as 8x minus x minus 4, common between the first two term. Yeah, common here between the first two term. Here we're getting only 2x as common. That's on dividing this by 2x, we are getting x. On dividing this by 2x, we are getting 4. Make sure when you take common between the last two terms, there is nothing common and there's a minus sign. So by default, it is minus 1 is common. Dividing this by minus 1, we'll get x, and dividing this by minus 1, you'll get 4. So clearly x plus 4 and 2x minus 1 are the two factors, right? As of now, we have factorized. Now, in order to get the zeros of this polynomials, what we are going to do is to equate this two factor individually with 0. Equating this with 0, we are getting x as minus 4. And equating the second one, that is 2x minus 1 with 0, we'll get x as minus on transposing becomes positive. So that is 1 by 2. Although we have two zeros here, that is minus 4 and half, we are asked only to get 1 0. Clearly, among the options, we have only half as one of the option and not minus 4. So that should be our answer. In the next part, that is question 11, we are asked to find the remainder when the first polynomial is this. The first polynomial is divided by the second, that is x plus 1. So here we are going to use the remainder theorem. In this remainder theorem, what we do, we equate this divisor with 0. First thing that we do is to equate the divisor with 0 as to get the 0 of this polynomial or the divisor, which is coming as minus 1. And in order to get remainder, the remainder, we are going to plug in the 0 of the divisor into the dividend. So now this is the dividend here is this, replacing x with minus 1. So it's minus 1 raised to the power minus 1 raised to the power 51 plus 51. Now remember that minus 1 raised to the power 51 is not minus 51 or it is not 51. You should remember that 1 raised to the power, right? Any number is 1, but minus 1 raised to the power, if it is an odd power, it will be remain minus 1. And in case if it is an even power, it will be positive 1. Over here is an odd power 51, so I wrote minus 1 plus 51. So it will give you positive 50. As you know, minus 1 plus 51 is 50. So this is the answer for this question number 11. In the question number 12, it says if x plus 1 is a factor of this polynomial, then the value of k. So the question once again, what does it say? It says if x plus 1 is a factor of this polynomial, if x plus 1 is a factor of this polynomial, then what is the value of k? So as you can see here that since this is a factor of this polynomial, therefore we can other way say that first thing that we can say that the remainder is 0, right? We can use the remainder. Remainder and factor theorem are very closely associated. So I can find the 0 of this polynomial. So what is the 0 of this polynomial? X plus 1 equating with 0. I got x is equal to minus 1. Now, since this x plus 1 is a factor of this, therefore replacing x with minus 1, we should get 0 as the remainder. So I can replace x over here with minus 1, and that should be equal to 0, right? I repeat, what we have here, we have x plus 1 given as a factor of this, right? So first thing that we do is to equate this with 0. That will give us the value of x as minus 1 in context of the divisor, and replace x with minus 1 to get the remainder. To get the value of x. So what we need to do is, you should know that minus 1 square is 1. So 2 into 1 is 2. And this is k into minus 1 is minus k equal to 0. Make sure when you have such kind of arbitrary constant or variable, if it is negative, transpose this as negative. Right. Why I'm emphasizing on this part? Because sometimes what happens, you transpose 2 on the other side and ignore this minus sign and you write k as minus 2 and it becomes wrong. So therefore, it is wise to transpose the one with variable or the arbitrary constant. So I'm transposing k on the other side. On transposing k on the other side, I'll get positive k. And therefore, the value of k is 2 here. So not minus 2. In question number 13, we have to figure out that x plus 1 is a factor of which of this polynomial. So we'll be using the factor theorem where we'll be equating this polynomial with 0. That means I'm going to equate x plus 1 with 0 to get x as minus 1. And one by one, we'll be placing the value of x in each case, the one in which we get 0 as the answer or the solution, that will be the 0 of this polynomial. So let's start with the first part. In the first part, I'm replacing x with minus 1. So clearly it is minus 1 cube plus minus 1 square minus minus 1. As you can see, this minus sign is as it is, and I've replaced this x with minus 1 and then succeeded by 1. Minus 1 cube, as you can see, it's an odd power. So it will be minus 1, even power, positive 1. This will give you 1 into 1, right? Minus 1 into minus 1 is positive 1, and this being positive 1. So we are getting 2 as the answer. So this is not correct. So this is not the x plus 1 is not a factor of this polynomial. Now coming to the next part, let's check for this one. Here also we are going to do in the same manner. I'm going to replace x with minus 1. So it's minus 1 cube plus minus 1 square plus minus 1 and plus 1. Minus 1 cube, an odd power. So it will be minus 1. Even power, so it will give you plus 1. Plus into minus is minus and plus 1 copied. This and this is 0 and this and this is 0. Yes, so we got this as the x plus 1 is a factor of this polynomial. So B is the correct option. In the next part, we have to find one of the factor of this. So we can see that here in this question, we cannot factorize. Even if I factorize this, the better way will be to expand. Let's first try by the method of factorization. I can write this as 5x whole square and this as minus 1 whole square. That's the first part. Plus is copied here. Yeah, you must be able to get that. I have factorized this, right? Replacing 5x whole square as 25x whole square as 5x whole square and minus 1 as minus 1 square. And in the remaining part, I'm going to write this as 1 plus 5x the whole square. Now I can split this as I applying the identity, second identity, a plus b into a minus b. So it's 5x plus 1 and 5x minus 1 plus 1 plus 5x is same as 5x plus 1. So I can change the order square. Now I can see that we have some common factor here. And what is common? That is 5x plus 1 is common. So I can take this number, this expression, that is 5x plus 1 factor as common. Now, if I divide this term, right, as you must be knowing, there are two terms only, not three terms. This is one term and this is the second term. So dividing the first term by 5x plus 1, I get 5x minus 1, right? This one. And dividing this second again with 5x plus 1, it is square time. So 1 times get cancelled and we'll get positive 5x plus 1. Now we can see that here minus 1 and plus 1 get cancelled. So 5x plus 5x is 10x. We have 10x and there's one more factor, that is this one, 5x plus 1. Now we have to find one of these factors, and I can see that here this is not one of those factors. Comparing with our answer, this is also not. 5x minus 1 again is not a factor in the solving part, but 10x is a factor. As you can see, this 10x is a factor there. So the correct option is D. In the next, that is question number 15. We have to find the value of this. Make sure in the examination also they will ask you using appropriate identity. And here you cannot find the square of this and square of this and subtract. Even if you go by this method and you get the right answer, if it is not an MCQ, uh, you won't get marks. Moreover, it will be very cumbersome if you go by this method of finding their square individually and subtracting. So what we can understand from here that replacing this with a and this with b, so we are actually getting a square minus b square, which is can be split as a plus b into a minus b using the third identity. Now, so I can say that 249 square minus 248 square can be written as 249 plus 248 and then 249 minus 248. Now we'll find the sum of this. 8 plus 9 is 17, 4 plus 4, 8 plus 1, 9, and 2 plus 2 is 4. And that multiplied by their difference is 1, right? These are two consecutive integers. So it comes out to be 497. This is question number 16, where we have to factorize this expression or this polynomials. You can clearly see that there is only one perfect square. This is not a perfect square, so it cannot be factorized by identity. In that case, we do middle term splitting, where we multiply coefficient of x squared, which is 4, with a constant term, that is 3, and it comes out to be 12. Now I'll split 12 so as to get 8. So we can write this as 6 into 2. So I'll factorize it. I'm writing 4x squared and writing this 8x as 6x plus 2x. The reverse is also true, plus 3. So we factorized it, and now we will we split it, and now we'll be factorizing. So what we are going to do, we'll take I can see 2x common between the first two terms. Dividing the first with 2x, this with 2x, I'm getting 2x. Dividing this with 2x, sorry, dividing this with 2x, we'll get only 3. Now I can see there is nothing common here, so we'll be taking positive 1 as common. Dividing each of them with 1, we'll get 2x plus 3. Now you can check 2x plus 3 and 2x plus 3 is common throughout the two terms. So take 2x plus 3 common. Dividing this first term with 2x plus 3, we are getting 2x, and dividing the other one, this one with 2x plus 3, we are getting 1. So clearly 2x plus 3 and 2x plus 1. So order does not make a difference. As you know, multiplication is commutative. So 2x plus 1 and 2x plus 3 is the correct answer. In question number 17, we have to find its factor. So to get its factor, as you can see that there is one common terms, x plus 1, or there's two ways. One, you can expand, that should be shorter. If you expand this and then take common, or conversely, you can write this in identity and then take x plus 1, x plus y as common. The simpler will be to expand it. Now, the first part, I'm expanding this using identity, a cube plus b cube. So this is a plus b whole cube is a cube plus b cube plus 3 times a square b plus 3 times a b square. And if I open this bracket, what I'll get? Minus x cube minus y cube. Now what we can see here that x cube and y cube get cancelled. So we are left with this. That is 3x square y plus 3xy square. Now since we have to factorize, therefore we should take common. I can see 3xy is common, so we're left with x over here and y over here. So we have two factors. One is this and the other is this. Comparing with the options given, only this is given. So 3xy is the correct answer. In question number 18, we have to find the coefficient of x in this expression, or in fact in the expansion. So in haste, most of you basically in haste write x, the coefficient of x as 1, as you take it as 1x. Not correct, because we have to find the coefficient in the expansion of this. So we first need to expand this using a plus b whole cube, which is a cube plus b cube is 3 cube, right, which is 27, plus 3 times a square, right, 3 times a square b plus 3 times a b square. Now this is x cube and this is 27. This can be written as 9. 3 into 3 is 9. 9x square, and this is 3 square is 9. This is 9. And into 3, that is coming 27x. So we were to find out the coefficient of x, and I can see the coefficient of x here is 27 and not 1. In question number 19, we are given this expression and we have to find the value of x cube plus y cube. So let's see what is the value of x cube minus y cube. So if I see x cube minus y cube, so I'm doing it. This is x cube minus y cube is actually x minus y bracket x square plus y square minus xy. This is what we have. Now we are given this. So in order to find the value, we should get this or this by solving this expression given. So let's check. If I solve this, like I'll solve this. This is writing this is x over y plus y over x is equal to minus 1. So clearly the LCM comes out to be xy, and this is x square plus y square is equal to minus 1. Later, I can see that if I transpose xy to the right hand side, it will multiply it with minus 1 and will get minus xy. And in one more step, we can transpose minus xy to the left hand side. It will become positive xy is equal to 0. Now check here, we got this expression as 0. And I can replace this same expression over here, that is x square plus y square plus xy with 0. So what we figure out, that if I replace this, like let's this with this only the left hand side, x minus y is copied, and then replacing this with 0 will get 0. So on solving, we got the answer this as 0, and therefore this is the correct option. So in the 20th question, we have to find the value of b, where we can say b is this. So what we need to do is, first of all, let me make some space. We can see on the left hand side, this is 49 times x square minus b. And we can see that on the right hand side, we actually have an identity. The expression is in the form of a plus b, a minus b. Considering this to be a, this to be b, so it's a plus b into a minus b, which can be written as a square minus b square. So I'm writing a, which is 7 here, a square minus b, which is 2 and not minus 2. So keeping the left hand side as it is so that we can keep equating with left and right. So 7 square is 49, x square, and half square is 1 by 4. So what in case if I cancel, like if I cancel this, and minus b is equal to, we can later write also that minus b is same as minus 1 by 4. So it implies that the value of b is positive 1 by 4. The value of b should be taken as positive 1 by 4. This is what we need to get. So we can even check the answer from here. Yeah, this is the correct answer. This is a direct question based on application of an identity. We should know that if a plus b plus c is 0, then a cube plus b cube plus c cube is 3abc, right? And it has actually come from the 8th identity, that when you know that a cube plus b cube plus c cube, let me write down properly. This is a cube plus b cube plus c cube minus 3abc, right? Its expansion is a plus b plus c, that multiplied by a square plus b square plus c square minus ab minus bc minus ca. Now, according to question, if a plus b plus c is 0, so if you replace this with 0 and 0 multiplied by any number is 0, so everything on the right hand side will become 0. So it implies that a cube plus b cube plus c cube will be equal to 3abc. Or if I do in one more step, I should first write this and the right hand side as it is 0. So we'll get a cube plus b cube plus c cube is equal to 3 times ABC when you transpose. But anyway, one should remember this as a direct identity, that if a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3ABC.